All right, so before break, real quickly, what were the things? Most of the stuff we did before break was skill stuff, right? We didn't put a ton of connections together. We started to, but we didn't fully get there. So what do we got in terms of the skills that we learned? Long division, correct? That's what we started with. Remember long division? We did long division. Okay, then what do we do the next day? Synthetic, because that was a nice shortcut for us. So if we had the option of picking between long division and synthetic, I personally would pick synthetic, but that would be up to you. Okay? However, you know that on other quizzes we've given, quadratic quizzes, like when we did completing the square and quadratic formula, that we specifically said in the directions, you must do, by completing the square, you must do quadratic formula on certain questions, right? So that still holds. You have to know how to do long division, and if the directions say you have to do long division, you have to do it, all right? But if you doesn't say, you can choose. If you like long division better, you can do it. If you like synthetic better, you can do it, okay? Everybody's clear on that? All right. And then what did we do after that? We started to put a theorem together called the remainder theorem. Anybody remember what the remainder theorem did for us? Well, it found the what? The remainder, based off its name. So it found the remainder. How did you find the remainder? It was a quick shortcut to find the remainder. Remember? You don't do something. You can, but you don't have to. All you want to know is what the remainder is. Remember what it said? So if you, so let's say you, I don't know, you're starting with like x cubed plus 2x minus 6, and you want to divide by x plus 2. And all I care about is what the remainder is. I don't actually want the answer, I just want the remainder. What did the remainder theorem say? Quick way for me to make that happen. So what it said was, if you take negative 2, and you put it into, this is p of x up on top, if you find p of negative 2, whatever that is your remainder. You guys okay with that? Okay? So if I take negative 2 and I substitute it in here, what's that going to be? Negative 8 minus 4 minus 6. So p of negative 2 is equal to negative 18. So that means the remainder, if I did this by long division or synthetic division, the remainder would be negative 18. Okay? That's what that says. So how does that help me? That helps me if all I want to know is the remainder. Or if I did synthetic division, I wanted to double check myself to make sure I didn't mess something up, then I should get the same remainder I get with synthetic or long division, right? So it's kind of like a quick way to check yourself. It also tells me that the point negative 2, negative 18, right, should be on that graph. Right? Correct? Okay. So it should be on that graph. So then we took the remainder theorem and we expanded it and called it the factor theorem. How does that help me? What makes something a factor? Yeah. If the remainder is 0. So special case, this would not be a factor of that because the remainder wasn't 0. Special case says if you end up with it being 0, it's a factor. Okay? So in other words, if you look at a graph and at negative 2 your graph crosses, then I know that x plus 2 is a factor of this equation. Attention right now, because this side is something really important. Okay? That if it goes through at negative 2, whatever this is, call it f of x, if I divide f of x by x plus 2, then x plus 2 will be a factor of this. It will go in evenly, remainder is 0. We're good with that? Okay. Moving on. All right, so today, some vocab. Standard form. When you go and put something like it for a quadratic, your standard form is ax squared plus bx plus c, right? Highest exponent to lowest exponent. Good there? That's the same for all polynomials. Standard form, descending order with your exponents. Okay? Degree of your polynomial is the highest exponent. Okay? And your lead coefficient is your value that's with your highest degree, but it's a number, not x. Okay? So, for this one down below, is the first one in standard form? No. What would you have to do to get it in standard form? Double distribute. I could go like this, right? Now, did the directions ask me to put it in standard form? No. They asked me to figure out what the degree is and what the lead coefficient is. Do I actually have to get it all the way into standard form to know that? No. I just have to know what would be the highest degree, correct? And what would be the highest degree here? X to the fourth. Does everybody agree with that? And so that value would be what? And there's no other x to the fourth I'm going to get, correct? When I double distribute, the other one's going to be x squared, right? Okay. So how many x to the fourth? 6x to the fourth. At this point, I should be able to answer this question, right? What's the degree of this equation? Degree is 4, highest exponent. That's the highest one I'm going to get. And my lead coefficient? 6. Now, if you need to do it all out, if you're not following me on why we stopped there, you can certainly double distribute and then put it in order and combine your like terms and blah, blah, blah. You're still going to get the same answer. Okay, what about for B? Sam? Agree? B coefficient? Good? Okay. Look at the graph. This graph right here is that equation. This is all the solutions to that equation. This is f of x. And they're asking you to identify the real zeros. Where the real zeros. Maybe? Where it crosses in this case. So where what? Yep. So I'm looking for some. So solutions when? Nope. When y is 0. So they're asking you to find solutions when y equals 0. That's what your zeros are, your roots, right? In this case, they're asking for the real solution. So where is y equal to 0 on a graph? Right along your x-axis, correct? Okay, so what are my real solutions? X equals -3. X equals -2 and x equals +3 would be my real solutions. Yep, when y equals 0.
Oh, no, I didn't hear.
Right? So that's only when y is equal to 0, correct? That's what you call zeros, roots. Okay? In this case, x-intercepts. All right, so again, our job for this course is to relate graphs to equations, equations to graphs, right? That's our goal. So that's our main connection today. So find all the roots, same equation as up above, but now you've never seen the graph, and you only have the equation, and you want to come up with the roots, but you have to do it algebraically. You're not allowed to use your graphing calculator, so now what? Yeah, I gotta set this equal to what? 0, because it's when y equals 0, right? So roots, again, when y equals 0. So 0 equals x cubed plus 2x squared minus 9x minus 18. So can I use quadratic formula on this? No, because it's not a what? Quadratic, correct? What makes something a quadratic? It's therefore you're allowed to use quadratic formula. 2. If the highest degree is 2, it's a quadratic. Then you could use quadratic formula or complete the square or whatever else, right? So I can't do that here. What do I need to do here then? The only method we've got here. Look for GCF. Do I have a GCF? Not across all 4. So what's our other method? Grouping, right? You do grouping. I got 4 terms, and see if you can come up with the same thing in both. So what's your GCF for these two? X squared left with x plus 2. So as long as I can pull out something out over here that'll leave me with x plus 2, I'm good to go with this method, right? So what do I got? Negative 9, and that leaves me with x plus 2, so I'm good. This is factorable by using grouping, not always factorable by grouping, but it is in this case. And then final step here, I've got another GCF of x plus 2that I'm going to pull out. So GCF one more time, x plus 2 left with x squared minus 9. So now I've done, right, now I've done my grouping, but Katie says, wait, this you can do dots, right? So this becomes x plus 2 times x minus 3 times x plus 3. There's your dots. Or if you didn't get that, at this point you could have split these up and you could have set that equals 0 and that equals 0 because it's quadratic. So you could do a quadratic formula or whatever on that. Okay? And now I got x plus 2 equals 0, x minus 3 equals 0, x plus 3 equals 0, so x equals negative 2, x equals 3, x equals negative 3. Did I get the same solutions that I got up above? Yes, good to go. So I can look at a graph and I can get those solutions. I can do it algebraically and get those solutions. We aren't really using any techniques. I could also look at this and say, factor theorem says that wherever y is, when the remainder is equal to 0, right, that this should be a factor. So if it's at negative 3, I should realize x plus 3 should be a factor, right? And x plus 2 and x minus 3, and weren't those the three factors that you got? You guys with me? When you're factoring, you're coming up with the factors. Good on that? Okay, let's try the next one then. All right, look at the graph. Here's the graph. This is f of x. Identify the real zeros. What do I got for real zeros? 0. X equals 0, right? And y is 0, x is equal to 0. All right, we want to do this algebraically, okay? So I'm looking for roots, so that's when y equals 0. Need solutions when y equals 0. So 0 equals x cubed plus x. Now what? Yep.
I just have a question. So for the top, do you know that x is 0 because of the type of graph?
By looking at the graph.
Okay.
Because I'm looking for where y equals 0,
Okay,
yep.
gotcha.
So I looked here and said y is 0 right there when x is 0. Yep. All right, what am I doing here? GCF of how much? X left with x squared plus 1. Okay, looking good. Dots? No, because that's plus 1, right? But it's a quadratic, so I could split it up here because I got ways to solve quadratics other than factoring, right? So I know over here I got x equals 0, and then I got x squared plus 1 equals 0. What are my options for solving this? Subtract 1, get x squared by itself, right? So x squared equals negative 1, then what? Square root. How many answers you get when you square root? 2 plus or minus square root of negative 1, which is really I. So x equals plus or minus I. So there are 3 solutions algebraically. That's a little bit of an issue for me, correct? So what does that tell me about the graphs? The graphs are only helpful if I'm looking for what? Real solutions, right? Because I'm graphing in the real number system, all right? So the graph is not going to help me find those imaginary solutions. I'm going to have to do that algebraically. I have no other option. Are you guys with me? Yep.
Is there any way to know when you're gonna have?
Let's just talk about that. Yeah, let's talk about that right now. Okay, so the question is, how do I know whether I'm looking for them or not, or if I'm good with the graph, right? Okay, so here's the key. There's a couple things we know about imaginary that we've already talked about. Imaginary roots always come in pairs. Conjugate pairs, to be specific, okay? So is it possible for me just to have the answer x equals I? No, that can never happen because they come in pairs, period. Okay, so that can never happen. All right, so the fundamental theorem of algebra, what this tells us is, if you have any polynomial, whatever the degree is of that polynomial is actually how many solutions you're going to have. Okay, so let's look here. If I have a degree 1 equation, give me an example of a degree 1 equation. Anything. So y equals x plus 3. That's a degree 1 equation. You got a degree? Okay, and you already know what that looks like. That's a what? The line, right? And it's going to cross the x-axis how many times? Once. So it's going to have one real root. Do you agree? Okay. Could it have imaginary roots? Nope, because there's only one solution, and imaginaries always come in pairs, right? So I know for a fact the only possible combination is I'm going to have one real root. Okay, what if it's a degree 2? Give me an example of a degree 2 equation. X squared, basic one, right? Parabola. Y equals x squared. Okay, so what's my possible? I know I'm going to have two solutions. What's the possibility? Yeah? Two imaginary. What do you know about the graph if they're imaginary? Both imaginary. What? The parabola is, open up above the x-axis or below, right? Open down if it's below. Okay, so it's possible they could both be imaginary, which means your parabola never crosses the x-axis, right? What else? Think about all the parabolas we've done. Could cross twice, right? And it could also be tangent, but that still means you have two solutions. But what do you know about the solutions? They were just the same number twice, right? So that's still two real. It's just they're equal instead of unequal. Are we okay there? Those are the only possibilities. If it's a degree 3, so like a y equals x cubed, which you're probably not sure what the graph of that looks like, but how many solutions are you going to have? 3. That's what this says. You're going to have 3 solutions. So what are the possibilities? 2 imaginary and 1 real. That's a possibility. Or what? That's the only possibility? That would be can I have 1 imaginary and 2 real?
No.
Nope, can't happen. 3 real. In other words, it could cross 3 times, right? Cross the axis 3 times, right? Or it could cross once and then something else going on with imaginaries. Okay, can I have 3 imaginaries? Nope, because they got to come in pairs, so that's out. What about 4th degree? How many solutions? 4 solutions. So what are my possibilities? 4 imaginary. What else? 4. 2 real, 2 imaginary. 4. 4 real. 3 imaginary, 1 real? Can't happen. So that just gives us an idea of what we should have, right? So now I answered your question, right? If you look at a graph like this and you know it's cubed and you see it cross once, you're like, maybe that means there's 2. There's a little bit more we gotta talk about, but then maybe there's 2 imaginaries there, right?
If you have for the last one, if you have 2 negative I, would that still count as separate?
What do you mean 2?
Like this, you get the same answer twice.
You can't have that with imaginary. They're conjugate pairs.
Okay.
Remember? Always conjugate pairs.
Okay.
They're never gonna be the same. Okay? Alright, we're good here? Okay. Alright, so let's answer some questions here about the different graphs. This is the picture of this equation, right? So you've got both. You've got the graph and you've got the equation. Our goal in the end, ultimately, just like with parabolas, is to be able to picture at least a little bit in terms of what it looks like without the graph, if I have the equation, that type of thing. Okay, or looking at the graph, have an idea what the equation's going to look like. So that's our goal here at the end. So anything between here or here, can you tell me what the degree is? What's the degree of the equation? 3. I can tell that from the equation here, right? So my degree is 3. Odd or even number? This one we should all be jumping on. 3 is an odd number. What's the lead coefficient of this polynomial? 1, right? Number that you brought here. So 1 is my lead coefficient. How many roots are there going to be? In other words, how many solutions when y equals 0 are there going to be? 3, the degree, right? Whatever the degree is, there's going to be 3 solutions. How many of them are real? 1. How do I know that? Can I tell that by looking at the equation? No, but I can look at the graph, right? So there's 1 that's real. All right, describe the end behavior. So now we're talking total ends, not what's going on in the middle, total ends, okay? So when I'm way over here, negative x values, right? I'm here. What do I know about my y values? Somewhere down here, correct? And the farther out I get out here, the farther down it is. You guys agree? Okay. So one way that you can write this, and you'll see it, is as x approaches negative infinity, so as it gets, my x values go farther and farther left. What do you know about the y values? Are they approaching positive infinity or negative infinity? Negative infinity. They're getting smaller and smaller and smaller, right? So as the farther left I move, the smaller my y values are. And as x approaches positive infinity, so now when I'm going in this direction from 0 over, right? What do I know about my y values? They're getting bigger and bigger and bigger. So they're approaching infinity. Then I know my y's are approaching infinity. So just know how to write it mathematically, because sometimes they give it to you in this format. Another way of saying this is your end behaviors, not what's going on in the middle. Your extreme ends are starting low and finishing high, right? Low to high. This is the mathematical way of saying low to high. Good so far? All right. Lena, how about this one? Degree? That'd be your lead coefficient. Lead coefficient is 1. What's your degree? Highest exponent 4. And that's an even number, right? Andrew, what was C? Oh, number of solutions. Number of solutions that you're going to get this equation if you were actually to solve it. 4. How many of those solutions are real, Zach? 2. End behavior. Who wants to give that a shot? As x approaches negative infinity, what do I know about y? Approaching what? Infinity. Positive, right? Getting really, really high up. And as x approaches positive infinity, move farther to the right, what do I know about y? Also approaching infinity. Or in other words, it opens up. Yep. For the, what was that, real solution? Yes. Let's look at that. All right. How about 3? I'm looking for the degree. Eric? 6. And it's even. What's the next one? Lead coefficient. Max? 1. Number of solutions I'm going to get. 6. How many of them are going to be real solutions? Katie? 2. End behavior as x approaches in negative infinity. What do I know about y? Sam? You are correct. And as x approaches positive infinity? Same thing. So it opens up again, right? So far? All right, John, what about my degree on this next one? 5. It's odd. Lead coefficient, Max? 2. How many solutions am I going to get, May? Careful. How many solutions?
Oh,
5. How many are real? 1. End behavior. Julia, as x approaches negative infinity, what do you know about y? And as x approaches positive infinity, what do you know about y? And so that really says the same thing as low to high. You're talking about functions. Are you talking about functions?
No,
Oh.
just for this, it seems like all the odd ones are really
Yeah,
high. Is that what we're
exactly.
saying?
That's what we're getting to. That's our conclusion. All right, so what do we got here? We got 2 more here to look at. Emma, degree. 5. Odd. D coefficient. F. -2. Number of solutions, everybody. 5. How many are real? 1. As x approaches negative infinity, what's happening to y? Positive infinity. And as x approaches infinity, y is negative infinity. Or in other words, high to low. Degree? 4. Even. D coefficient? -1. Number of solutions? 4. How many are real? 2. As x approaches negative infinity, what's happening to y? Negative infinity. As x approaches infinity, what's happening to y? Negative infinity. So it opens down. So again, our job for looking for this was to try to come up with ways that I'm not going to have both. So what would I know just by looking at the equation or just by looking at the graph, right? I should be able to go back and forth. So the key that Sam said is, look, it has something to do with odd and even. You've already done this. Just think about a parabola. When you look at a parabola, right? It either goes like that, the end behaviors are either both up or they are both down. How do you know if it opens up or down? The coefficient's positive or negative, correct? So that nothing new here. If it's an even degree, so now if it's y equals x to the 4th, what do you know about the end behavior? Uh-oh. Y equals x to the 4th, what do I know? It's going to have the same end behavior as any other parabola, because it's even, right? So it's going to open up. Okay, now what goes on in the middle in between, I don't know. But I do know the end behavior, all right? So if it's an even degree, I'm talking even functions, because we did that also, that's something different with the symmetry stuff. So conclusion. If degree is even, then the end behavior is either open up or open down. Those are the only 2 options. Again, what's going on in the middle? I don't know. But the end behaviors, when it approaches negative infinity, when it approaches positive infinity, I do know. Okay, now, how will I know whether it opens up or whether it opens down once I decide it's going to be one of those 2? I look at the lead coefficient. If it opens up, that meant the lead coefficient was what? Positive. And if it opens down, that meant my lead coefficient was negative. Same exact thing you did with parabola. You're just expanding it into anything that is an even degree polynomial. You okay there? You actually have done odd degree also. What function do you know well that's odd degree? Nothing. Y equals x, or y equals x plus 2, or whatever, right? Y equals x plus 2. Isn't that an odd degree? What is that? It's a line, correct? And what do you know about the end behavior of that line? Should be up on through 2, but it is low to high, right? Or, if I make that negative, it's going to go this way, correct? High to low, right? Depends on what your slope is or your lead coefficient. Okay? So if it's an odd degree, then the end behavior is either low to high
May I have your attention, please?
or
The 5-hour course scheduled for today after school has been canceled.
high to low,
The next
right?
class will be
Low to
after
high or high to
4:06.
low. If it's low to high, what do you know? Think lines. What do you know about the lead coefficient? Positive. Lead coefficient equals positive. And if it's high to low, your lead coefficient is negative. Go, Pekka. Good so far. Okay, I'm gonna throw this at you semi-fast, but it's actually stuff you've done. Just we gotta put it all in pieces together here as much as we can. And we can do some more tomorrow because we gotta review that, all right? You've got this polynomial right here, which I'm giving you the graph for. This is the graph. That's p of x, correct? And I wanna know, they wanna know, find all roots. Okay, so tell me things you know about the roots. How many roots are there? 4. 4 roots. How many of them are real? 2. What does that tell you about the other 2? The other 2 are imaginary, which means I'm going to have to do algebra to get there, correct? So from graph, 2 are real. 4 from here, correct? Very good so far. Okay, so how am I going to break this down? Because I can't group this. There's no GCF to do algebraically, right? So what do I know? Well, I know that right here, x equals -2 is a root. Right? I already know 2 of the 4 roots, correct? X equals -2 is one of them, and x equals 3. I've already got 2 of the 4 answers. There they are. Straight off the graph. Those are the real ones. You guys with me? How am I going to find the other 2? Well, if x equals -2 is a root, what do I know is a factor of this? X plus 2, correct? Okay, so that means that p of x should be able to be written as x plus 2 times something, right? And what's going to be this value right here for sure? X to the 3rd, blah, 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 whatever it is. How do I find the blah, 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 blah that we did before break? Synthetic division, right? So what goes in the box for synthetic? What's one in the box if that's going to be a factor? -2, that's that value right there, right? So -2 goes in the box, and my lead coefficients are 1, -2, -1, 2, and -24. If I did this right, what better be my remainder? 0, they're already telling me it's a factor, right? So 1 is -2, is -4, is 8, is 7, -14, -12, +24, there's my 0, correct? That's my remainder of 0. So now I know this is x cubed minus 4x squared, hang on, plus 7x minus 12. You guys with me so far? I still can't factor this, but I know that 3 should go into that, right? So I can take 3, put it in the box, and now do it on x cubed. And now I'll be able to break it down to an x squared. And once I get to x squared, I'm good to go because now I can do quadratic formula, I can do other things. You guys with me? Okay. If you get stuck on this last piece of your homework, we'll talk some more tomorrow. But you should be able to do all the end behavior stuff. Right? I'll finish this one.
I'm gonna go Thank you.
Yeah.
Class average was 76. What are you doing that? Well, that's for.
Which way, I'm gonna do it food and then I'll be back to I literally just made myself just do it.
Where is it? Where is it?
Over there behind me.
Oh.
Thank you. Yes, but I said
Okay, so now I'm going to the next step where I'm taking the other zero. Oh wait, you got it. Oh. Okay, so you already did -1. You also know that +1 is a 0. So now you're going to take +1 and put it into this. So now you're going to be able to go +1, which is the other 0, right? Into the coefficients of 1, -7, 16, and -10. Well, it's still gonna be, it's still, this whole thing is equal to that. But this piece of it, if it's a 0 on the original and it's all equivalent multiply, it's still gonna be a 0 of this. It's still gonna be a factor of that. Okay? So when I do this, here's 1, -6, -6, 10, right? See, it's still a 0. Okay, of the whole, even though I'm only doing this piece, it's still a 0 that entire graph.
X plus 1, X minus 1.
Great, so now P of P of X is equal to X plus 1 times X minus 1 times X squared minus 6X plus 10. And now you're quadratic, so you're good to go. If this isn't factorable, you could set equal to quadratic formula. Okay, so now this is 0 equals, right? X plus 1 times X minus 1 times X squared minus 6X plus 10. And so now you can split them up, and you can say X plus 1 equals 0, so X equals -1. X minus 1 equals 0, so X equals 1. You're already moving the graphs, right? And then this, again, if it was factorable, you could just do it, but I don't think it is, right? So X squared minus 6X plus 10 equals 0, and then you put that on it.
Okay, so
So, okay? Yep.
hi. I got to run down to the graph papers because we're gonna start with the beginning of unit 5 here next week.
And I'm just gonna go over the skills that you didn't have time to do these different skills.
Yeah.
Just gonna let you read that quiz.
Okay.
Okay, so we'll put you back in those skill ones. Let me grab the stuff from her and then please grab it from her. You ready? You understand what I'm saying on that one?
Yeah.
And then you don't have midterm stuff yet, right?
No, we just got it.
You got it today? Okay, beginning of the stuff, but you guys start.
Yeah. Okay, so get it set up for me. Put in your like things that are equal. You got your calculator?
No, it's
Okay. Let's look at those first. So we gotta figure out how to work with exponents, right? So here's the deal. There's no, so see how this exponent is an exponent on the outside, and then there's inside, that's different, right? same letter or just numbers? Okay, so what do you see that matches up? Like what, if you looked at these as individual pieces, what would you say matches up? There's a B2 here and a B2 there. If you were counting them up, how many B's are there in here? Technically, B squared means how many B's? 2, right? Because B squared, what it means is B times B, right? So that means there's 2 here, right? And how many here? 2. So you have a total of B to the 4th. Okay, so we've got a B to the 4th. What else do you see that matches up? X. Okay, so how many F's can you then count them? Okay. And they're all next to each other, right? And what else matches up?
Nothing else, what's
The A, right? Along with the 3. How many total? Well, how many total A's do you see? How many are sitting here? And how many here? So total, so A4, right? And then what's the only other thing that's there? The 2, and you're doing what with them? Multiplying, there's no add, right? There's no plus in between them, multiply. Here, slide it over. Okay, so that would be your final answer. All, nothing including the pluses, right? It's all multiplication. Okay, you try this. Okay, so what do you got? So you gotta mark this, right? Okay, this should be marked, right? Get it? Okay. And you said consecutive sizes of your rectangle, so let's mark that. This and this. Okay, you're trying to get those triangles, right? Okay. What else do you see? More old stuff. See that you have vertical angles, so we're gonna talk 1 and 2, right? Go back.
Is it this one?
Do you see, what is it? Is it?
Review quiz number 2, quarter 2, algebra 2 AB.
Right? Okay. Alright. Vertical angles are congruent. Okay, so now you got this. Alright, and you're trying to figure out, like, this is more or less than what you want. More, right? So your goal is to get this, correct? And you have too much. So what would you have to get rid of? You want to do subtraction, but you can't do it because you don't have, what would you need to know in order to get subtraction to happen? And get to what you want. So there's like 2 thought processes here. You know you want to get to this equals this. What would you have to subtract from the whole angle to get there? You would have to know that this, for some reason, equals that. If you knew that, then you could next step subtract. Does that make sense? Okay. Do you have any reason that you'd be allowed to say that those are equal to each other? Something they told me in the proof. Now, do you understand my thought process on that? How did I get to that? I was like, wait a minute, this is too much, and I want to get less. What would I need? Because of mom. You see what I'm saying? Okay, so see if you can write that out. Okay, so -8. Good. Okay, so now, you get to here, and you can't just do x squared, right, because of this, because it's on the outside. So what does that mean? It means this entire parenthesis has to be written out how many times? 3 times. Okay, so in other words, I could write it like this. Negative xy once, negative xy twice, instead of this 3, like I'm getting rid of that 3, right? Negative xy, so this, and this is the same thing as that. And then what I throw in, x z. Now that I got rid of that on the outside, I can do what I did up here. Okay, so now figure out what those would be. You don't have to show subtraction anymore. Remember? Okay, so all you have to be able to show. So first of all, mark this. Right? Okay, and you know what's going to be your answer. You see you have subtraction because you got a hole and a piece mark and a hole and a piece mark. So you know you got everything in here you need. Yep. That would be what you'd write down, and your reason would be, yep, 1 step.
It's a reduced slope.
Yep.
It's a B.
Yep. Yep. Yeah, okay.
And
Yep.
then.
Yeah, that's it. Yeah. Negative 1. Okay. Now what other
First.
Let's go in order, what's the next letter?
Oh,
X,
X.
right? How many do you count all up? Four. What else do you got?
Oh, wait.
What? Yeah.
Oh, wow.
So Y, third, yeah. And then one, two. So that would be enough. Okay, so now, what do you gotta do here? Write that parentheses twice, right? Think you got it now? Okay. So then you got the triangles, right, by angle, side angle, and then FE and E. Right, and that would be that, right, yep. Alright, what else you got for me? You would take that quiz, right? What are the, we've gotta go through all of your, so there are proofs on it, okay, but that's not the, you gotta know your kite stuff. Okay, so you gotta know your rectangle rhombus things well, okay, and how to prove them and all that stuff, okay, and how to use them. And then you gotta refresh yourself on your kites, square, and your kite stuff. All right, so a lot of this is old stuff. You gotta figure out like isosceles triangles versus congruent triangles, okay, and that the diagonals and perpendiculars is really the only thing you know about a kite, but then all the rest of it's old stuff, and you don't put all this stuff together. So definitely you need to go back and look at, you need to do this stuff and make sure you know all your kite stuff, all your rectangle stuff. Parallelograms obviously because they all relate, okay? So there's like a lot on there, all right? You're welcome to stay. You can also work on midterm review in here on regular basis. Okay.
And then,
Let's see what you got. So you did 22 times 22, right? But now, okay, but you didn't break the whole thing out. Remember, you have to write the entire parenthesis twice. What's the entire parenthesis? Right? Squared, then B3. And then 0.2 A squared B3, right? Okay, now go from there. So you already did this. Right? Okay. How many A's do you have? What do you got here?
I mean,
2.
oh,
Mm-hmm. That would be. Mm-hmm. F1. Okay, alright, so now, same idea, but now we're doing area, right? Express the area of the figure, okay, well, how do you find area of a rectangle? Yep, so right there, area equals, just, if I can put just 2B, yep. L times W would be times. Okay, so now fill in your length, so A equals. Fill in your length, what's your length, put in parentheses. Yep. Yep. That whole thing times. So use parentheses, doesn't it? Confused with what that means times if you put a parentheses next to each other like that, right? Okay, and so, finish up and write it as a monomial means it has to be one like this. This is a monomial, there's no pluses and minuses in between, not two parentheses, right? Okay, so how do you simplify that? That becomes what? Yeah. to your final answer based off these directions, wanting a monomial, this is a monomial, okay? And that's your area. Alright, so I'm gonna equal that. Now, for the quiz, are you gonna have to, do you have to memorize all your formulas, or did she give them to you? Okay, so area of a circle is area equals pi r squared. That's your formula for a circle, right? Okay, and you fill in, pi is just a number, right? But r into what in this? Is r radius. And what's the length of your radius based off the picture? Right? Okay, so A equals except for all your formula, what's it say? I forget.
Oh.
That, right?
Oh.
And then when you fill something in, you have to leave it in parentheses, right? Like you're replacing it.
Wait,
Yeah, follow your formula. Instead of R, what are you replacing it with? Right, separate would be, yeah, so that just moved down, correct? And then instead of this, you're putting that, what are you putting in parentheses in place of R? This, but now what's still in part of the formula? Squared on the outside. Okay, so how are you gonna simplify that? So it's, again, kind of going back up to here. What do you do with this? You still have that out technically in front, right? Which you're not worried about right now. Okay, now you gotta be careful. Yep. Okay, so, see how this is in parentheses? That's the only thing that goes with the 2. Not this. You see what I'm saying? Okay, so this is gonna go here by itself, right? And you're moving that down, and then this goes with that. So you're writing that up. Okay? There wasn't up there like that. Alright, so now what do you got? Let me see that. And it's still up, it's still there. Right. Which is probably put over here, but it's not. Assuming you put the number first. Okay? Alright, so now you're doing volume. So this is 3D, right? Open 6. How do you do that? 6. Yeah, you too. Remember how to find triangle? So rectangle is this times this, right? But this is only half of it, correct?
Yeah.
So it's base times height or length times height over 2, right? Okay. Or the half of how Yep. Yep, parentheses here. You know what you said. Right, over.
All of it?
Yep. Take care of the top first. A equals.
And then, oh wait, no, that's
And then your last step is, this is a number, that's 2, so we can go into this, right? And then we did that. So it's divided, right? 24 divided by 66 on the bottom. So 24 divided by 2. So what's your final answer here then? 12 cubed C your final. Okay, kind of follow me there? Alright, so now let's try this one. now it's volume, so instead of just base times height, what do you do? Base, yeah, width, and height, right? Okay, so that's volume, if you're filling it up with water type thing. Mhm. Okay, they wanted a monomial, so you're gonna have to combine these, right, like you were doing before. Mm-hmm, yep, mm-hmm, yep, mm-hmm. Calculator for you, mhm. Yep. Oh, that's V, right? Okay, you want those, Mm-hmm. Different letter, yeah. Mm-hmm, you can put ones in front of it, but one times one times one.
Yeah,
One
one.
down there. It can be there or not, up to you. You don't have to put a one in front. If they're your M's.
Does it matter? Does that
So if it.
Oh, wait, that
yeah.
was.
Right. One, yeah. And then you've got a cylinder, right, which is just, you gotta find, basically you have to find, you have to find the area of a circle and then multiply by that. That's just, okay, let's just practice some more of these first. Okay. Let's see that last one. Let's do it. Okay. All right, so this one, look, you could just, this is all numbers, correct? There's no letters? These are your regular. If there's letters like X's and A's, you don't know what to deal with it, right?
Like that?
Yep, actually, yep. Your answer. Now, you can't do that with this one because it's A's and B's. Okay, so here's your rule. This is basically the rule. I'm gonna write it out once, okay? A to the fourth means, we're talking top and bottom, right? A to the fourth means how many A's? So you could write it like this, right? And then this would mean 2, 3, 4, 5, 6. You get that? And on the bottom, you got how many A's? 1. And you have how many B's? Okay, so if you have like 6 divided by 6, that always equals 1, right? So A divided by A becomes a 1. And B divided by B becomes a 1. Right? And B divided by B becomes a 1, and B divided by B becomes a 1. Okay, so you got nothing left on the bottom, it's a 1, right? And then on top, you have what? So A cubed B cubed would be your final answer. Okay, now, your rule is this. See how this is A to the fourth and this is a 1? When you're dividing and the base are the same, right? Let's cancel the A's. You can subtract your exponents. See, that's where you're getting the 3. And here you had 6, and you subtract 3 from it, and you get 3. So you can think about it as I'm writing it out, or you can use the rule. Okay? But, okay, so see what we got going here. Whatever you think is easiest. Start with your numbers. Remember, you're still doing the same thing when we were going across. You're matching up the things that are the same, right?
Wait, what, the one on the line?
Yep. So right now, you're really just, if I gave you this, could you do it? Well, what would you get? Careful. 8 divided by 4, right? 2, right? Because 2 times times 40, does that make sense? So this part right here becomes 2. Now, go to your y's. Okay, can you picture writing that out? You'd write out how many y's? 7 of them. And on the bottom, you'd write out 6 of them. Can you picture crossing them out? Would there be any left? Where would it be, top or bottom? How many? So y on the top, which is it. There's the bigger 8's on top, right? So 8, 2 would be on top. Okay, how about the z's? Can you picture writing them out? How many? So how many crossing them out? Any of these left? Where? How many? How many? Okay, so try this one. Do your numbers first. Adjust the numbers. The -4 divided by 24. You can use your calculator, right? Don't leave it as a decimal. Math. Either use your fraction key or hit math and then. No, go over to 1. Okay, so equals, and you need a -1 on top, right? And 6 on the bottom. Okay, now you gotta fill in your letters. Alright, so can you picture writing them out? Can you picture writing them out? How many would cancel? Are they all gone when you cancel? How many are left? Where? Okay. Put them on the bottom. Next to the 30. Okay. Alright, so now you're here, right? How about, okay, you're talking negatives. Okay, ready? You're talking negatives now. See how there's a little negative in that exponent? Okay, so. So, I'm not gonna hear him say this, but if you have y to the -6, you know how you would write this like y over 1, top and bottom, right? If you want this exponent to become positive, which we do, okay? Anything, this is the base that goes with it. We're gonna push it, this is the magic window, right? Push it through the magic window and this will become a positive, okay? So basically, I'm gonna take all of this and push it down, okay? So now it's gonna be y to the +6. And on top, there's nothing up there, so it's a 1. Okay, so how about this one? Right? Am I gonna do anything with this? No, because it's positive exponent, right? That's gonna stay right there. And then what about this one? Now what do I want to make that? So how you gonna write it? Take y to the -5. Now push it down. So what's left on top? 1 over, but now it became, goes to the magic window, becomes positive. Okay? So this right here is 1 on top, this is a 1 on the bottom, right? Okay. What about that one? Okay, so now, things on top, things on the bottom, right? Here's an x. Are there any x's on the bottom that you can combine it with? Okay, so picture, how would you write that out? How many would be up here? How many would be down here? So how many do you have left, if any, and where? Where? 5 at the bottom. So I'm gonna write x5 down here, right? So technically gone, right? Okay. And then what else do you got going? On top, all I have is what? 1 times. 1 times 1, so 1, right? Okay, and then what else do I have on the bottom? 5th, no, nothing else to put with it, right? So that's gonna stay on the bottom. Okay, got lots of rules going on here. All right, so let's try this one. What do you remember about this? How do you deal with that? Yep. Okay, so do that. Can I see your pencil? I probably still will. Let's do it. bottom too. Whole parentheses. So all of this. 3 times. Okay, so I would do, as if there's no bottom, I would do this top first. And make it all, what is it be funny? What was your numbers first? Now I think they're the whole bottom. There we go.
Oh.
Yeah, no, you're good. Yeah, same thing, but on the bottom, which we could have done that up here, maybe I should have done that up here. Okay, and then I gotta look, and I gotta say, okay, now I've got division, right? So I'm back to what like you did here, right? So you should be able to use your calculator. Put that in the fraction, see if it'll- like what you did here, we did the- what's the number? Okay, so what's on top? Okay, then it doesn't reduce, so you leave it. 64 is still on top, 97 is still on the bottom, okay. Now, what other letters do you have? F's, right, any other F's you can combine with? Okay, let me say. Any other G's you can combine with? No, any other H's you can combine with? No, put it on the bottom, so we would actually don't know where that is. Okay? Let's see, how about this one? One more paper. Okay, right, thing on again. Alright, so you can do that. Take care of the bottom first. Or write it out, so you can take care of the bottom first. Yeah. Yeah, that's the bottom, then, so leave that on the bottom, put this top up here. Leave it on top. Right, put that right on top. So it's going here, this one. Now, are you done, or can you do more? Right, so. Okay, so what are you left with on top? One what? R, so an R, right? And then what are you left with on the bottom? Okay. All right, so then they just get tricky, like in the sense of, okay, so let's try this one. See how there's no parentheses? Don't have to do any of that, but I have this one little negative exponent. And I want these all to be, like, this is positive, so we'll leave it. This is a positive exponent, we'll leave it. And numbers, we don't move, right? Negative numbers, we leave, okay, but exponents. So what goes with this exponent? What's the base that goes with this exponent? Yeah, so, okay, so this is what I mean, like, x to the third. What's the exponent? It's just like that. 3. What's the base? The x. But if I do this, what's the exponent? What's the base? Nope, just x still. If I do this, what's the exponent? What's the base? See that parentheses? That means this whole thing 3 times. So this means this, right? This means only the x 3 times. That makes sense? And this means just the x 3 times, without the 2. You see the difference? Okay. So, on this one, all right, what goes with this exponent? What's the base? S, right? Is that? Okay. Okay, so I want to take the exponent and the base, and I want to push it up through the window, because I want that to become positive. So, but I'm not going to change anything else, except for the S and the negative 3 going up. So, what do I still have on top? What do I have on top? S3 on top, right? Okay, so what else is on top? 22, r to the third, S2, and now I have S3 next to it, right? Okay. On the bottom, what do I have? Okay. Now could you combine? Start at the top, find things that you can combine, right? You can, but you got some things you can combine here also. It's up to you. You can do it either way.
I just put it up
Okay, thank you. What else you got?
there. This time.
Okay, so what we said with this is we need to be able to factor this, right? But, so we're gonna use the graph to help us. We know that there's 2 real roots. The other 2 are gonna be imaginary. I know there's 4 because of that, right? Okay, so the 2 real roots are x equals negative 2 and x equals 3. Okay, so I just need to find 2 more, right? So now how can I do that? Well, I know that negative 2, that x plus 2 is a factor of this because negative 2, remember the remainder is 0. If I fill in negative 2 and I get 0 as a remainder, then x plus 2 is a factor. Okay? So I know that p of x is going to be x plus 2 times something, because that's going to be a factor. Okay? So I'm going to use synthetic division to figure out what the something is. Fill in negative 2, 1, negative 2, negative 1, to the negative 24. If this is correct, I should get 0, right? Based off this graph. Okay, so you can do that part for me. Alright, what you got?
I don't know if I did it.
Alright, so 2 was good. You made that s to the 5th, right? And then, okay, and the r is on top because there was 2 on the right, 3 on the bottom, so you're good. Okay, so they just get more complicated, like, okay, so now look at, this one. Try this one. Yep. What do you want to move? Which things do you want to move before you start combining anything? What things do you want to make the negative exponents, right? Okay, so can you rewrite it for me? Just moving the negative exponents and leaving other things the way they are. What's going to be on top? 8c to the third still, right? Yep. What about that? B squared, right? F4 is still there, right? You go to the bottom. What's still on the bottom? 4. Nope, not c to the negative 1. You said you wanted to do what with that? Okay, but the 4 you don't want to move, right? Okay, so the 4 stays. What else is staying on the bottom? B squared, right? Okay, these 2 are going where? Up. Okay, so what's this going to become when you move it up to the top? To 1, c to the first. So put c to the first on top. And what? Yep. Yep. And now you're ready to do what you need to do. So now you can combine things on top, right? And then work with the bottom. All right, did you get that synthetic?
Yeah.
Okay. Okay.
And then the factor that.
Yeah. Okay. What do you got for homework tonight? And do you know what you're doing? The stuff you're doing in class right now?
Oh, we're supposed to do the
This? This what you're doing? Perfect. What things are you doing? So you should be able, definitely should be able to do that as we worked on that today, right?
Oh, we already did some class.
We have to do the odds. Okay. I'm gonna. You'd have to write this out first before you started. Actually, I'm gonna tell you the rule on this. It's gonna allow you to do with the rules. Multiply your exponents. So it'll be your parentheses in that case. So this becomes z to the multiply to this exponent.
Oh,
What's
to the
that?
6.
To the 6. And then w, multiply those together. -3, and then this one multiply. So z to the multiply,
Oh,
6, and then w to the 4, and then window, and that's got a negative left. Like we did, okay? I don't know what else you gotta do, and there's some of this getting covered, but you have to do all the odds.
Wait, that's not the one.
This is, I don't know, she gave me another one to do. Test review? Not that either. Alright, I don't know, these are the ones she gave me to work on, not this, return review.
No, not the one.
Okay. Alright, well, whatever you gotta do, alright? We'll keep working on this stuff so you can get you ready to take the quiz. Alright, and. You gotta get this done, okay?
Yeah.
All right, you got some busted here, 2.5 weeks of like, I can't study enough. All right? Okay, bye, I'll see you in a few. All right, finish this one. So you got what? X, what? Okay, so x third minus 4x squared, right? Plus 7x minus 12. My issue is, maybe if I could group this, I'd be good, right? I could take out an x squared, that would leave me with x minus 4, but that's not gonna become an x minus 4. You agree with that? So I can't group this. Okay, so now what? Well, I happen to know the other answer is x3, right? And I don't have to put it into the whole thing. I can, if it works in the whole thing, it'll work in this as well. Okay? So basically what I'm gonna do is I'm gonna do the same thing, but now I'm gonna use the other 0, I know. It has to be a factor, okay? And I'm gonna use that on this gradient. Okay? So 1, -4, 7, -12, right? And if this is true, I should get a 0 here, right? It's supposed to be a factor. So 1, 3, -1, -3, 4, 12. Yep, it works, right? So what does this do for me? It tells me that, move the x plus 2 down, right? And now, what did that just break into? What times what? That, x squared minus x plus 4, times what? X minus 3. Good so far? Okay. If this is factorable, right? If it's factorable, 4, 1, no good, 2 and 2, no good. Okay, so if it's not factorable, I can do quite, right, like I can split these up and I can say, well, I know x plus 2 equals 0, so x equals -2, which I already knew, right? And x minus 3 equals 0, so x equals 3. And this, x squared minus x plus 4. If I can factor it, great. If I can't, I can do quadratic formula to find the irrational roots. Okay? Actually, there's no way this is irrational. I take that back. This is gonna have to be quadratic formula. How do I know that? True, but there's only 2 real roots based off the graph, which means the other 2 are what? Imaginary, and the only way I can get imaginary is quadratic formula. Yep.
This one? That one? How would you start that?
Okay, that's, so you're gonna use this graph to help you. These are your real roots.
There's 4,
There's gonna be 4 solutions, and you know 2 are gonna be real, given, you already know what they are. They're x equal -1 and x equals 1. And then you're gonna have 2 that are imaginary. So the only way I can find the imaginary ones is if I can get this to the point where I have an x squared and then do quadratic formula. Okay? So in order to get it to something times something equals x squared, really what I know is, this is what I know. Based off of this, I know that since -1 is a solution, what do I know is a factor of it? X plus 1 is a factor.
Oh, yeah.
Right? So equals x plus
Yeah.
1 times x minus 1. That wouldn't give me this, that would only give me x squared. Times x squared something. Okay, well, the only way I'm gonna find the rest of this is if I start breaking this down by using my synthetic derivative.
Okay.
So, Since I know -1 works, right? We can start with that. 1, -6, -6, -10, right? It should get 0.
Yeah.
I know it's supposed to be a factor, I'm looking at the graph. So bring the 1 down, -1, -7, 16. Right, so this would be p of x equals x plus 1 times that, right? X
Oh,
cubed
okay.
minus 7x plus 16x minus 10,
Okay.
okay? But we also know that x minus 1 is supposed to go in, but
Yeah.
we're not gonna go back to the original. We know x minus 1 should go into this as well,
Okay.
okay? So now we're gonna take plus 1, right? Because the other 0, but we're gonna do it into this to break this down.
Okay.
So 1 negative, what's that? Negative 7, 16, negative 10. You see what I'm doing?
Yeah.
Should still get a 0, because we know that it's a factor,
Yeah.
okay? So 1, -6, -6, 10, 0, so that works. So now you realize, I just did it on one step here. From here, you realize that this is still there, x plus 1, right? This is your x minus 1 factor,
Yeah.
the remainder of 0, times
So with this step you figured out there was x plus 1, but this step you figured out.
that is x minus, this you figured out what
It
goes
has
with
to
both
be
of
zero
these,
because here-
right? Because that's a 0, the original.
That would be the
Yeah, so this is equivalent to that, if you were to back
Yeah,
again,
okay.
okay? And this is also equivalent to that, but it doesn't help me enough because I can't group it
You're
or
gonna get
anything.
that.
Yeah, I don't have a cubed, I don't have as many
Yeah.
ways to solve a cube,
Okay.
right? Plus, I already know what the two real zeros are, I don't care. I wanna get it to a quadratic so I can find the imaginary. Okay, so now I know this is x squared minus 6x plus 10. I know this is 0 equals, so I can find my roots,
Yeah.
right? X plus 1, x minus 1, x squared minus 6x plus 10. So now I'm ready to, I already know these, but x plus 1 equals 0, so here's my x equals -1.
Okay.
X minus 1 equals 0, there's my x equals 1, which I already knew,
Okay,
those are
yeah.
factors. And then this, I gotta do my quadratic formula, x equals negative b, so 6 plus or minus 22, do my quadratic, b squared minus 4ac, right? B squared is 36, minus 4 times 1 times 10. Now it's gonna leave me with -4, so that's even for that factor, that's gonna be -4
Yeah.
under here, which makes sense, based off my graph, I knew I was supposed to get imaginary, right? So that gives me x equals 6 plus or minus 2i over 2, or x equals 3 plus or minus 9.
Okay.
So, 1, 2, 3, 4 solutions.
Okay.
Which I knew I'd get 4 solutions because it was x to the 4th,
Yeah. Yeah.
right?
So you have to get 4 solutions
Yep.
from that.
Now, that doesn't mean that
It's all gonna be the
they,
two.
yeah, I mean, if they're real, they could be the same solution
Yeah.
twice or whatever, you know what I
Yeah.
mean? But you should have 4 solutions, okay? Bye, thank you.
I'll go right back to you.
Yeah, I didn't really want,
But like, yeah,
like, tomorrow.
there was just no way.
Like, it doesn't make sense. That's again, I don't understand why we do it, but it is.
I get it, it's not, but like, I don't think we know like using one, but whatever. We started with number 3.
Nope.
So I number 1 with her. So yeah, we're doing great.
I don't know what to do, but I don't know why.
Yeah, and I need to like know why,
Yeah.
like.
Yeah.
Are you keeping this out?
No, I got backup anyways, what's up?
I have a question, okay, so, you know here, so you know if it's a three, it could be, we wrote here that if it's a three, it could be two imaginary, one real, or
Yep.
three real. But here there's two real. Right?
Right, oh, you're right, that graph is, ooh, we didn't fix that. Yeah, that can't be the graph for that, that's not possible.
Okay, yeah, that's why I was a little confused.
We, it can't even happen, because odd degrees should be low to high or high to
Yeah,
low, right?
exactly.
So this isn't the right graph for that. Oh, you know what it is? No, I know what it is. Never mind. I do remember what it is. This is only looking at part of it. It actually, I think, turns around and comes back down.
So that would be.
Or back this way, so it hits it 3 times.
Okay, but knowing that, you know that it's three real.
You know, right, you would know this has to be 3 real. I think this was the right, but it's confusing because we don't see the rest of the graph.
Yeah.
So I think it's okay, but you don't see the rest of the graph. Well, let's check. You can check by the zeros. So your zero should be -2, right?
Yeah.
So let's see if it goes in evenly. 1, 7, 4, -12. We should just figure it out. This should be -2, 5, -10, -6. So it is a 0.
Yeah.
And then it would break into that, and then it would be +1, 1, 5, 6, right? 1, 6. Yeah. So you're just not seeing the whole graph.
Okay, that's
It
good.
either turns around and comes back down this way or this way.
But here they started right. 'cause it's-
Actually, lead coefficient's positive, so it should be coming this way, over here.
Yeah. Low to
Yeah,
high.
low to high.
Yeah.
So it should be something like that.
But here, like, would this just be X and then you turn it?
It would be x plus 6. So no quadratic.
Oh,
Right? It's gonna have 3 factors
Yeah,
because
yeah.
it's 3
Okay,
solutions,
yes.
and they're all real solutions.
okay, cool.
Okay, so at -6, this would have come back down.
Okay, cool. Thank you.
That makes sense?
When you do number 1, I got one, a negative 1, and then
Right, because those were already given, yep. And then you did a
Uh,
quadratic formula,
3 plus or minus I.
Yep.
And then how do you write that?
x equals.
So how do I write
You don't have to write a factor form, you're finding the roots.
oh, okay.
So your roots are these two, this one, and this one.
Okay.
Those are your 4 roots, if you will.
Yeah.
Okay? So you should have 5 solutions. When you're done. You have 5 x equals. Okay? For that one.
Okay.
You go with something like
Oh, I have a question on the review. Well, it says like f minus 1. Is that like the
F to the -1 power, you mean,
Yeah.
of x?
Yeah. I don't remember if I did that, but I think.
So if it was like 3x minus 3, it would be negative 3x plus
So if it was what? You have to be y
It was like-
equals or something like that. You put a y equal?
Cool, yeah.
You'd have to switch the x and the y.
Okay.
When you switch the x and y, it becomes the inverse. Okay, but then if you want it in the format f -1, you'd have to get the new y that's located over here now by
Yeah.
itself. You'd have to do the algebra to get it by
Okay.
itself, basically.
So the inverse of this like
The inverse means
Y.
switch x and y.
equals 5x plus
So the inverse of that would be 3x equals
5y.
5y. So then you'd have to solve for y if you wanted it in that format,
Yeah.
f of -1.
Okay.
But you usually have to solve for y.
I know it now. I just
But like if they were looking for, f of inverse of 2, right? Then this is the inverse, and you could just take the 2 and plug it in there and solve for y. You know what I mean?
Yeah, I just like
You don't have to solve first.
I plugged in like 2, but I just didn't do the inverse.
Oh, yeah. It's not, you're not asking for f of 2.
Yeah.
You're asking for when you put 2 into the inverse, what do you get?
I was trying to figure out if like the -1 for inverse was like that.
It's
or
not
if it, or if it just meant another equation.
It's not an
You know what I mean?
exponent, like,
Yeah.
because
Yeah, I just like I
Yeah,
wasn't sure
you
if
know
that
what
was like another
it's not
equation.
like this.
Yeah.
X to the -2 power.
Yeah.
It's f of
Yeah, I just felt like the -1 meant like another equation, but with that like input in.
Oh, yeah. Gotcha.
Am I supposed to be getting a remainder on number 2? Cause I keep getting a
No.
remainder when I do that.
You shouldn't, not if it's a factor. What are you putting in?
What crosses at -2?
So then you should be putting -2 into the box,
Oh,
not +2. X plus 2 is your factor, but that's not what you put in the box,
Yeah.
right?
Yeah.
Whatever your 0 is what you put in the box for synthetic.
Wait, I'm not getting 0 here for when I put 0 in.
So does it not cross at 0 then? Yep. Assuming that's a 0. So.
Oh, that's.
Yeah. So this is. So this should always be 1 less than the beginning, so this should be x to the 4th. You had it, alright, so it should have another 0. Use this in a placeholder.
Okay.
So you're saying this
Yeah, okay.
But it changes your coefficient. So, this was your original, so x plus three,
And that's minus three.
right, so this is x plus three.
And that's zero.
And then this is 0, and so now you're to here. It's this. All of this is like you're doing here.
When I put the one in.
Yeah, the one has to be there.
How come in like,
Because look, when you go to write this out, it is x plus 3
oh, you're right,
times x to the 4th, right? One less. This one, because you're going from x to the 4th, is gonna be x to the 3rd times that. Do you see what I'm saying? So this is
Can't just
x,
skip.
you can't just skip, no. So this is x to the 4th minus 3x cubed plus x squared minus 3x plus nothing, so you don't have a number,
Yeah.
right? And now you're gonna take that, and it's gonna be x plus 3 times x technically. Now honestly, this one, so you're making this a little bit harder than you need to, because you should have DCF'd your x out to begin with.
yeah.
You shouldn't have jumped right on synthetic. If x equals 0 right there, that means you have a DCF of x. So I would have DCF'd out the x.
Okay.
So I would have started with, you see what I'm saying there? I would have started with, q of x equals x times x to the 4th minus 8x squared minus 9, right? And actually, this really is just gonna factor in the x squared minus 9 adds together to give you -8 should be, minus 9 plus 1
Okay,
with the x there.
that would be the x plus three.
This would
and
be your x
minus
plus
three.
3, x minus 3 for your real pieces. And this is your imaginary piece, which you can solve because it's now quadratic. Okay, so this is your x equals 0, this is your x equals 3, this is your x equals -3, and this are the other two. Like you don't need, you need to
Yeah.
try to do other things, or when you can't do other things. I couldn't group this, I went and simplified it. Then I'm gonna always check whatever I get and see if I can do something with that. You know, I might be able to group this, I would look for that
Yeah.
first. Okay, and then I would go from there.
Yeah. You just dump to it, 'cause
Like it gives you alternatives, you can't always group, so then I gotta use that idea.